Hey everybody, welcome to video 44. Today we're going to be covering other glands of your endocrine system. Now this is the final video in our nervous system series. So once you are able to be done with this one, you are done for the semester, and there is even no quiz over this video. So we're going to start off with the thyroid gland. The thyroid is a butterfly-shaped organ. It's going to sit anterior to the trachea. It's actually going to sit up here in your throat. Thyroid gland is going to produce thyroid hormone, as we talked about in a previous lecture, it's going to be stimulated by thyroid-stimulating hormone produced in that pituitary complex. It's going to be relying on iodine ions in order to be able to do this. Those iodine ions are important for everything that you have to do with that thyroid. That's why we now have iodized salt. We started to go through a period in time in history where we noticed a lot of people did not have enough iodine, and there's a disease associated with your thyroid when you don't have enough iodine in your diet. So we thought, well, salt is something that everybody eats, so there is an easy way to iodize salt, and so that is now how we get iodine into our diet. Thyroid hormone is going to be used to increase our metabolism, and is also going to play a role in development of the nervous system, but with a slow metabolism, especially one that is slow to the point of causing other disorders, the thyroid hormone may be in play. The thyroid will also produce calcitonin to lower blood calcium levels. You may remember calcitonin stimulates osteoblasts when we covered this in our skeletal system. And those osteoblasts are going to pull calcium from your bloodstream and deposit it onto your bones. And so that's one way that you can not only lower your blood calcium, but also strengthen your bones. So you can see here where that thyroid gland sits. So right here, this thyroid cartilage, you can see the hyoid bone, and then your Adam's apple here. So it's going to be slightly inferior to your Adam's apple, and then it's going to sit spanning across that cartilage there. You can see kind of that butterfly shape that it has. Here from a posterior view, so this is looking from behind and looking forward. Obviously that trachea is going to be in front of it. But you can see where actually the parathyroid glands are located, and we're going to talk about those next. So your parathyroid gland, they're going to be embedded on the posterior side of that thyroid gland like you saw. Their job is to release parathyroid hormone in order to raise the body's blood calcium level. So it's going to be just the opposite as that calcitonin, where it's going to be stimulating osteoclasts to collect calcium from your bones and release it into your bloodstream, and thus raise your body's blood calcium level. So here you can see some pictures of blood. This would be where a blood vessel would be passing through. In this section, you can see the parathyroid cells going around all the way here. Next, we have your adrenal glands. These are going to be a pair of pyramid-shaped glands that are going to be superior to the kidneys. They'll actually sit on the superior margin of the kidneys. Their job is mainly to respond to stress in a couple of different ways. So hormones such as cortisol are going to be released by the adrenal glands. They're going to stop the building of tissues and actually promote nutrient breakdown, because you think if you're breaking down those nutrients that are stored, they're going to be available for you to use. Think of this as sort of a fight or flight type of thing. You don't want to worry about building any muscle or anything like that. You want everything to go towards being able to outrun or outfight whatever it is you are facing. Epinephrine and norepinephrine are the names we give for adrenaline and noradrenaline. You'll see those used interchangeably. But their job is to increase your blood glucose levels. So again, more sugar in your blood means it can be carried to your muscles, and you can outrun or outfight whatever it is you're faced with. It's also going to increase your pulse and your oxygen delivery. Pulse just because your heart's beating faster, and it can carry that blood throughout your blood system faster. And if your blood is traveling faster, you're going to be able to carry oxygen faster. You'll also get aldosterone released by the adrenal glands. That's going to regulate your electrolyte levels. So that's going to be things like your salt levels. And in doing that, what they're really trying to manage is your blood volume. So if your blood is too thin or too thick, it can alter the amount of electrolytes you have in your body. And then based on the amount of electrolytes you have in your bloodstream, your body is going to adjust the amount of water that is in your bloodstream to make it either thicker or thinner. So here you can see the pyramid shape of the adrenal gland, taking a look at all the different areas and what hormones are going to be released. You can see the adrenal cortex and the adrenal medulla here, medulla just being the middle, cortex being the outer portion here. You can see there you even have the cortex broken down into 3 different areas. One thing I will say about those hormones is that this fight or flight response does not necessarily mean you are faced with a bear or something that is. A lot of people that deal with anxiety and stress have problems with all these hormones because their body is constantly believing that they're fighting a bear or something like that. And so it's constantly releasing these hormones, which causes a lot of issues with the digestive system as well as just with their overall health. Next, we have the pineal gland. It's a very, very tiny gland. You may remember it from when we dissected those brains. It was basically the size and shape of a pea. Going to be responsible for releasing melatonin when light is decreasing in your environment. So this is your day-night sleep cycle here. As it is getting closer to nightfall, there's less light stimulating your brain, and so your pineal gland is going to start releasing melatonin to make you sleepy. This is why the blue light of phones can play a negative role in our sleep cycle and in our sleep habits, because we are basically maintaining the same level of light stimuli to our brains. And so our pineal gland is not releasing melatonin because it is not sensing that it is getting late or that it is getting dark. The gonadal glands, obviously you're going to have your male and your female gonads. These are something we will also talk about when we get to the reproductive system in Unit 9. So the testes are the male gonads. They're going to be responsible for producing testosterone in males. Testosterone is going to promote secondary sex characteristics as well as the maturation of sperm cells. Testosterone is also produced in females, but in very, very low amounts, although it can alter based on different body compositions. The ovaries, which are the female gonads, are going to be responsible for producing estrogens, which is going to be the female version of testosterone, basically, where they are promoting secondary sex characteristics development. They're also going to play a role in regulation of the menstrual cycle and the maintenance of a pregnancy. So when we are developing those secondary sex characteristics in males, that is things like body hair and a deeper voice. In females, that is things like breast development and hip widening. And then with the regulation of the menstrual cycle, maintenance of pregnancy, we'll really get into that during the reproductive system. The ovaries, not only are they producing estrogen, they're also producing progesterone, which also plays a role in that menstrual cycle in the maintenance of a pregnancy. Then we get to the pancreas and the kidney. The pancreas is going to be, pancreas and kidney are going to be in the bottom half of the stomach, especially posterior of that stomach. They're going to be responsible for secreting several important hormones. One of them is going to be glucagon. Basically, it's going to do the opposite of insulin, which we will see here. I believe it's next. Yep. Glucagon and insulin are opposite sides of a negative feedback loop, where glucagon is going to travel to your liver and tell your liver to release glycogen, which is a form of glucose that is usable by your muscles. And so basically what's happening is that glucagon will stimulate the liver to release glycogen into your blood. And so you're going to raise your blood glucose levels, especially when you're hungry or you haven't eaten for a while. You need that sugar. Insulin is going to do the opposite. So insulin is going to be released by the pancreas, and it's going to stimulate a decrease in blood glucose levels, because what it does is it makes all of your somatic cells, your body cells, pull glucose into themselves. And so you get less glucose in the blood, more glucose in those cells. The kidneys are going to be secreting erythropoietin, abbreviated EPO, which stimulates the production of red blood cells. So actually some long distance athletes, be they cyclists, cross-country runners, especially like marathon runners, actually can misuse erythropoietin and use that as a drug basically to increase their red blood cell count. Because with more red blood cells, you have more things able to carry oxygen. And if you're able to carry oxygen at a higher level, that means you're able to maintain whatever sort of activity you're doing for longer periods of time. So that is all we have on your other endocrine glands. Again, this is the last video of your nervous system / endocrine system video series. So let me know if you have any questions, and hopefully you're glad to be done.